Welcome to this tutorial on creating ERC-20 tokens. In this video, you'll learn how to build your own custom token on the Ethereum blockchain. ERC-20 is the most widely used token standard, powering thousands of tokens including popular cryptocurrencies and DeFi projects. By the end of this tutorial, you'll understand how to create, customize, and deploy your own token. ERC-20 stands for Ethereum Request for Comment 20. It's a technical standard that defines a common set of rules for fungible tokens on the Ethereum blockchain. Think of it as a blueprint that ensures all tokens work in the same way. This standardization allows tokens to interact seamlessly with wallets like MetaMask, exchanges like Uniswap, and decentralized applications. Fungible means each token is identical and interchangeable, just like traditional currency, where $1 equals another dollar. Every ERC-20 token must implement 6 required functions. First, total supply returns the total number of tokens in existence. Second, balance of returns how many tokens a specific account holds. Third, transfer allows users to send tokens to another address. Fourth, approve lets users authorize another address to spend tokens on their behalf. Fifth, allowance checks how many tokens a spender is still allowed to use. And sixth, transfer from enables approved addresses to transfer tokens from the owner's account. These 6 functions form the core of every ERC-20 token. In addition to functions, ERC-20 requires 2 events. Events are signals that notify external applications when something important happens. The transfer event is emitted whenever tokens move from one address to another, whether through a direct transfer or an approved transfer. The approval event is emitted when an owner grants permission to a spender to use their tokens. These events enable wallets and block explorers to track token movements and display transaction history accurately. To create your own ERC-20 token, you'll need 3 essential tools. First is Solidity, the programming language used to write smart contracts on Ethereum. Second, you'll need a development environment like Hardhat or Remix. Hardhat is a command line tool for professional development, while Remix is a browser-based IDE perfect for beginners. Third, you'll use OpenZeppelin, a library of secure, audited smart contract code. OpenZeppelin provides battle-tested implementations of ERC-20 that save you time and reduce security risks. Let's look at the basic structure of a token contract. Every Solidity file starts with an SPDX license identifier for licensing purposes. Next comes the pragma statement, which specifies the Solidity compiler version. Here we're using version 0.8 or higher. Then we import the ERC-20 contract from OpenZeppelin. This gives us a pre-built, secure implementation. Finally, we declare our contract called myToken and use the is keyword to inherit from the ERC-20 contract. This inheritance means our token automatically gets all the required ERC-20 functions. Every token has 3 important properties. The name is the full descriptive name of your token, like my custom token. The symbol is a short ticker, typically 3 to 5 characters, like MCT. This symbol appears in wallets and exchanges. The decimals property defines how divisible your token is. Most tokens use 18 decimals, just like Ether. This means if you have one whole token, it's actually represented as one followed by 18 zeros in the contract. Using 18 decimals allows for very small fractional amounts. Here's a complete functional token contract. Inside our myToken contract, we define a constructor function that runs once when the contract is deployed. The constructor takes one parameter, initial supply, which determines how many tokens to create. We call the parent ERC-20 constructor with our token name and symbol. Then we use the _mint function to create the initial supply of tokens. The mint function sends all tokens to message.sender, which is the address deploying the contract. We multiply the initial supply by 10 to the power of decimals to account for the 18 decimal places. OpenZeppelin provides optional extensions to add powerful features to your token. The burnable extension allows token holders to permanently destroy their tokens, reducing the total supply. This is useful for deflationary tokenomics. The pausable extension adds an emergency stop mechanism. When paused, all token transfers are blocked, which can protect users during security incidents. The mintable extension allows authorized addresses to create new tokens after deployment. This is useful for tokens that need to increase supply over time, like rewards tokens. You can mix and match these features based on your token's requirements. Deploying your token involves 4 key steps. First, compile your smart contract to convert the Solidity code into bytecode that the Ethereum virtual machine can execute. Second, configure your deployment network. Start with a testnet like Sepolia or Goerli, which uses free test Ether, before deploying to mainnet. Third, deploy the contract by sending a transaction that includes your initial supply parameter. You'll need to pay gas fees for the deployment. Fourth, verify your contract on a block explorer like Etherscan. Verification publishes your source code and proves it matches the deployed bytecode, building trust with users. Let's recap the key points. ERC-20 provides a standard interface that ensures all fungible tokens work consistently across the Ethereum ecosystem. The OpenZeppelin library offers secure, audited implementations that protect your token from common vulnerabilities. Always test your token thoroughly on testnets before deploying to mainnet to catch bugs and ensure everything works correctly. For production tokens that will hold real value, consider getting a professional security audit. Even small mistakes in smart contracts can lead to significant losses. Now you have the knowledge to start building your own token. Good luck with your blockchain development journey.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.